All right, welcome everyone to the February OpenZFS meeting. We have a couple of interesting things on the agenda for today. Update on the block reference table with Powell, encryption bugs. Let me see, Rich said he might not make it. So we'll see who would like to go over that. And then a question about the Blake 3 checksum. Powell, do you want to get started?
Sure. Okay, I get my notes. Okay, so just a reminder, BRT is a block reference table, is in some way similar to dedupe. It allows to manually clone specific given blocks. It's similar to reflink from Linux, basically, and we can clone individual blocks or we can clone whole files, but the idea is that we only create block pointers that will point at existing data and will keep track of those in a similar way to the dedupe, that we have a separate table that we keep those extra references. Okay, so I think the code is like, I would say 98% ready. I was sidetracked a bit with a small security issue in ZFS, but this is really minor. So, and I think we almost have final patch ready to be merged, hopefully. So after my last update, there were some changes. For example, there was some interaction between dedupe and BRT. So there was some we could, if we had a block that existed in both tables, we had to choose from which table it should be freed first. And both selections have some implications. And Alan came up with an interesting idea, which I implemented, that if we are going to clone a block that already has dedupe flag set, we will just increase the counter in the dedupe table, and we won't put this block into BRT at all. So we will be reusing what's there already and not creating another entry. So I think that was a very good idea. The code is ready for also situation where, even though the block has dedupe flag set, it doesn't exist in BRT, because we hear about those ideas to be able to remove some blocks from dedupe table, especially those with just one reference. So I wanted the code to be ready for that. I implemented some missing bits to try to close and complete the implementation. So stuff like enforcing file size limit, range locking of the source files, enforcing quotas, passing IO flags so we can tell if we should use ZIL or not, update A time on the source files, on the source file, and stuff like that. The ZFS clone file function initially was in the FreeBSD specific code, but I rearranged the code to have as much system independent code as possible. So most of the code is now available to everyone to use. I implemented fclone range system call for now, because the code itself allows to clone blocks, but the syscall I implemented initially allowed only to clone entire files, because that will be probably the most common use case. but I also added, because it was simply easy to do, fclone range syscall that allows to clone any sets of blocks, even within the same file, as long as the ranges don't overlap. Also, I fixed a bug where it wasn't possible to read from cloned blocks before transaction group was synced. So that was fixed. And one of the big missing bits was ZIL support. So this is now also implemented. So the problem here was that this cloning blocks is a bit different than all the other system calls and operations, because we can have source and destination files in different data sets. So for ZIL, I didn't want it to reference data set that it's maybe, I don't know, not yet available for some reason, or so I didn't want it to use file IDs from different data sets. So I had to implement replay totally different. So now I log just BPs that I want to clone, and I don't reference the source file at all. So the ZIL support is implemented. I wanted to thank Christian for his reviews and comments and discussions. So thank you, Christian, for that. Apart from that, I think some tests would be nice to have. So I would appreciate if someone point me at the right direction, how we could test that, or if there's any similar, maybe how the duplication is tested now. So maybe I could work on something similar. And there's also one more item I'm thinking about implementing, because now the block reference table is a single large table, and the key into the table is VDEF ID and offset. So we have those two 64-bit values as a key, and the counter, of course, is the value of the element in the table. But the VDEF ID repeats often, right? If we have just a bunch of VDEFs, then most of the keys share 50% of the. So basically, we have so we have 24 bytes of data, right? 16 bytes for the key and 8 bytes for the data, and so 33% of this repeats almost in every entry. So it's probably not a huge space savings, but it just bothers me that we are repeating everything. So I'm just considering to splitting BRT per VDEF. So we won't store VDEF ID anymore. Just the key will be the offset, and each VDEF will have a separate table. And that's pretty much it.
I mean, that would impact memory usage as well, right? Like you would hope that this BRT is mostly cached, right?
Not really. Not sure if I mentioned that in the past, but one of the big problems was that when we free a block, we have to look at the BRT table, because we don't have like special bit as for the duplication. For the duplication, we only consult the dedupe table when the bit is set. For BRT, we don't have that. But what I implemented to make this work better than the duplication, and it can work better with the duplication because the key is not random, so it's not spread across entire pool. Now I split VDEFs in ranges, like every few gigabytes, and I keep how many references are within this range. So this array of ranges and those counters within ranges is very small. I think it was like uh, 1 MB per 1 TB, or even smaller, something like that. So it's very small. So what it allows us to tell is that if there might be, if the given block might be in the BRT. So if it is, then we will go and consult block reference table. But we can immediately tell if it's not. And so if we clone even a very large file, chances are all those blocks will be within a single range. So there will be just single entry. With the duplication, because we use cryptographic checksum, this will be spread across entire pool. So for dedupe, it wouldn't work, but for BRT, it works very, very well. But yes, if someone will use BRT very heavily and have clones across entire pool, like then yes, that would impact memory as well, I'm sure, because of course we want to cache as much as possible. So this entry now will be, if I implement this tweak, it will be just 16 bytes per block. So
yeah, you might even be able to get away with like a 32-bit ref count, saving even more space there.
Yes, even for yeah, the offset also might be we can use the you can use blocks for offsets, not but it won't save us a lot. So instead of using byte offset, we could use block offset, let's say, so we save a few more bits. But
yeah, you could do that, and then like either use those bits for the ref. There might not be enough bits there to use for the ref count, but you could like use those in case the ref count overflows the 32 bits, or maybe the ref count is 16 bits plus the height plus the bits that you have left over in the offset, you know, something like that, to squeeze as much as you can to fit stuff into memory. I don't know if it's worth it to go quite that far, but
yeah,
saving a third of it seems like it probably is.
I think with those counters within ranges, I think it's no longer like a huge problem. I think the problem was solved with this one. So before, it was a concern of mine that we'll basically end up with the same problems as deduplication, but
how big are the ranges that you're chunking it into? So like
I don't remember exactly.
Like the smaller those ranges are, the better chance you have of getting one that's ref count of 0, right?
Yeah, of course.
So I mean, hopefully, like you have enough memory that to store those, even if they're pretty small, like I don't know, 16 meg or 128 meg or something like that.
Maybe I can look it up quickly, but so now I'm using 1 GB. So, and this, so with 1 GB range, we need 8 kilobytes of memory per 1 TB of VDEF.
Yeah, I mean, I would consider going like, so you could cut this. You said that the range was 1 gig. You know, you could go to 1 meg and still it's 8 megabytes of RAM per terabyte, which is like, I mean, that's way on the other end of the spectrum, but I think somewhere in the middle probably will make sense.
But 1 GB, I think it's, well, I was actually surprised with the calculations, but for me, even 1 GB was like very small, because normally when you clone a file, you probably want to clone pretty large file, right?
Okay.
So 1 GB file is not that big, and the whole file should fit into a single range, because most likely the blocks are contiguous on disk. So
yeah, I guess I was thinking that people might use it to clone like a bunch of smaller files, like, you know, it's not just like my one disk image, but, you know, once this is available and easy to use, people might be like, oh, like I'm gonna CP-R all of my photos that are each like a couple megabytes. And CP is just, you know, using your BRT under the table to not have to actually copy the data. Then, you know, you might have a lot more small files that might have been allocated like, you know, all over the place. Not necessarily tiny,
I know
like
what
1 kilobyte
I know
files,
what
but like medium-sized files. Like,
I know what you're saying, but just to put it into perspective, like we now can have 1 megabyte record size, right? And with this space optimization, let's say we have 16. So for those blocks that are 1 megabyte and for ranges that are 1 megabyte, it's a matter of like if this range table takes 8 megabytes for 1 terabyte, or if BRT takes like 16 megs per 1 terabyte. So it's not. I think one.
yeah, if you have those big blocks, then you probably aren't having problems at all with it, right? Like the whole BRT will be cached in RAM, right? So I guess maybe the argument that you're alluding to, which I think I agree with, is like either you're cloning files that are laid out that are like have large record size, in which case the BRT is small, or you're cloning files that have small record size, in which case the files are likely very large, right? Like if you're cloning a large file like a disk image or a database or something, then those are the cases where the records where you'd have small record size. Medium-sized files wouldn't have small record size. And so that's kind of why the solution might work out really well, because like either you're cloning these medium-sized files with large record sizes, in which case the number of entries in the BRT is small, or you're cloning these huge files that have small, may have small record size, but they're laid out, you know, in sections of the disk that you can use this like summary info to at least reduce the cost of the BRT manipulations for freeze of things that are not actually involving it.
Yes, image files are a good example because those are large files. They can have small record size and they can also be scattered across the pool once you start to use them. So yeah, I don't really have a strong opinion. I was thinking that 1 gigabyte is already very small
Okay.
range, but we can always go smaller. That's not a problem.
Yeah, I mean, it seems like you have the flexibility to go at least, I mean, maybe not to a megabyte, but like to, you know,
Somewhere in the middle.
yeah, somewhere in the middle, you know, a tenth of that or something, and your memory
Yeah.
costs are still tiny.
Yep.
So then you know you're using that to reduce the cost of the freeze when the BRT is not involved. You still have to worry about the size of the BRT for those small record size, small record size cases when you are like actually freeing one of these cloned files, right? Because you're going and decrementing the ref count then.
Yeah.
Yeah.
But here, when we are freeing, there is not much. Well, we have to pay the price. Like, still, we have some savings, so we are not really freeing the data, just in decreasing reference. But apart from like trying to get the entry in the table as small as possible, I don't think there is anything we can do.
I think that makes sense. I don't know if you've already done this, but the table has an entry for each logical block. Is that right?
Yeah. Mm-hmm.
Have you considered, like, in the case where you have some giant file and like you said, it's probably laid out, you know, in the same region of the disk, and then you clone it. I wonder if you could like indicate in your data structure that like this whole range of bytes, the ref count is 2, and that range encompasses multiple blocks that are all contiguous on disk.
I know it's tempting to do that, but I suspect it would be huge complication to the whole code to try to, when you start to like cloning just ranges in the middle of this and try to split.
And
yeah. So I don't want this to be, I think that if we decide it's worth doing, I think we can, this can be done later, because we can always split larger block into smaller blocks and find a way to, like in the future, to just combine them or something like that, just by editing the table. So I don't think that if we even go with this code, it doesn't like prevent us to do that in the future. Like we are not committed to anything that will prevent us to do this in the future. But I definitely would prefer not to do that now, because I expect huge complications with.
Yeah, that's fair. I agree. Sounds like you're really far along. Like this is getting really real.
Yeah, I think it's pretty much almost ready. I regret I stumbled upon this security issue, because this took a while. But yes, the code is pretty much ready.
And for the logging that you mentioned, I assume like the overall clone operation might be like cloning some giant file, and I assume you're like splitting that into smaller log records, where it's like just like when you do a huge write system call, we split it into like 1 meg or something log records. Are you doing something similar where it's like actually the atomicity is, or the like, the durability into the log is on a 1 meg or 1 gig chunk that you can collect all of the block pointers and log it together?
Yes, I pretty much mimic what's how write is done.
Okay.
So I split those, of course, into larger chunks than writes, because I'm just storing BPs. But yeah,
cool.
Each chunk is stored in separate transaction. Sorry, no. It's stored in separate records in the log.
Yeah, like different transactions in the in the.
But cloning is also, cloning itself is also split into ranges as well, just like writes that we open
like different DMU
separate transactions. Yeah.
Cool.
I haven't had a chance to look at the latest revision. So which syscalls are hooked up to this mechanism right now? You talked about fclone range or whatever. I think that's a FreeBSD thing.
No. Those syscalls, both syscalls are new. There are nothing like that. But in FreeBSD, you can implement syscalls in kernel module. So there is fclone file, where you can clone entire file, and fclone range, where you can clone just selected range.
Are you planning to, like, are you aware of a Linux syscall that provides similar functionality, or are you like planning to implement any of that?
So I'm not really planning to do that. I hope it will be easy enough for someone to do that based on the syscalls I implemented for FreeBSD. But I think that in Linux it's either ioctl or some other way to use reflink. It's not really a syscall, as far as I remember.
For reflink, I think that should be.
macOS has a separate system call to do that.
Okay.
But macOS also, the difference between macOS and what I did is that they have like a clone file system call, where you provide paths to the files, not file descriptors. And I decided that I don't want to replicate entire logic of copying, because the clone file in macOS tries to copy all the permissions or the ACLs and stuff like that to the target file. And I decided that I don't want to really duplicate this logic. You can always just use open to create the file and just pass this descriptor to fclone file.
Okay. I did a very quick Google search and found copy file range for Linux, but I don't know whether, like, what the cloning semantics are. And I think Alan pointed that out as well. So FreeBSD has it as well.
Yes, I think that when I looked, the reflink in BRT, in ButterFS was implemented using ioctl. I think it wasn't system call, but maybe something changed, or I don't know.
No, I think it's actually still a system call, or not a system call, sorry, an ioctl. But it would be kind of cool to wire up, because then all of the existing command line tools would just be able to use it and it would just work on Linux, which would be pretty cool.
But it should be possible to implement it as an ioctl for Linux, right?
I don't see why not.
Yeah.
Pavel, a small question. You mentioned it implemented for files. What about zvols? Is it general enough to be used on abstract any object?
Yes, I forgot to mention that, but yes, it can work on zvols just as well. I didn't came up with any interface to do that, but you can definitely do that on zvols too. We just need some kind of system call or some way to some interface to do that, but it can be done on zvols definitely.
I just really like it to back VAI iSCSI or float. It would just map, like, read here, right there. It would just map one area of zvol into another area of zvol, or maybe different zvol within a system, within a pool.
Yeah,
that's what I was thinking too, is that you could use it to implement that iSCSI offload stuff, and just, that way your VMware or whatever just says, I want that over here, and you can do it almost instantly instead of having to actually physically copy the range.
Yeah, right now in CTL just practically reads here, right there, trying to pipeline, still faster than full copy. Science skips network, but still a lot of overhead. It'd be nice just to do it.
So I wasn't aware about this in iSCSI. Yeah, that's why I didn't want to implement something, because I was suspecting there is something exists already, and so yeah, but definitely it can work with zvols.
Yeah, so it sounds like the interface is like you have a new interface that you've implemented for FreeBSD. I think it would be probably important for people, for like this to be used widely, to kind of hook it up with the most popular existing interfaces, which is probably I'm guessing the Linux reflink stuff. So, maybe when you're ready, we can try to find, who would be interested and able to work on hooking that up. I think that would increase the utility of this a lot.
Yeah, definitely. Reflink, as far as I know, currently in Linux is used by XFS and ButterFS, right? So definitely, if we will just use the same mechanism, it would be immediately available.
Yeah, it would just work with all the tools that were written, for Reflink.
Yes, for FreeBSD there is nothing like that as far as I know. So we will still need to work on the tools to be able to use that. Although I was also wondering, and maybe you guys have an opinion on that, about implementing some kind of like daemon that can work in the background and find stuff that can be deduplicated. Of course, with snapshots, it won't work exactly as expected, but it also so the idea for me was that the daemon would walk through file systems and just read block pointers and checksums. So it should be much faster than reading all the data. So we would need an interface for that as well. And then when we find duplications in the data, then we could use BRT to clone like older block to the newer one. And even if we have snapshot, the older block would stay, but the newer block wouldn't take extra space. So I think it's not. It might be.
You cached it before the snapshot comes in, right?
Of course, yeah, that would be best.
And once it's BRT'd, it has the same DVA, so you end up only caching it in the ARC once, which can help there as well. You know, I think my initial idea for this is even maybe not going as far as a daemon, but just a command line tool to be like, I cloned this disk image months ago. Can you go through it now and find any blocks that have changed since I cloned it, but are the same again now? Like I installed the same Windows update in 2 VMs or whatever. Or especially things that were actual like ZFS clone, like dataset clones. And they've just diverged a lot. And can we find blocks that are common between them and turn them into references instead of taking up the extra space?
Yeah, well, the daemon would be nice because I think that there are some systems already that use offline deduplication like that. That when the machine is like less busy, the daemon will just start and walk and try to find what can be deduplicated. And especially if we will came up with an interface that can read only block pointers, so this should be much quicker than just reading all the data. And based on the checksums, if it's not secure checksum, then we will of course compare the data as well. But if it's but still, so this daemon could be really like quick. And also if we can also came up with interface that allows us to swap blocks without even because of course we are working on a live file system. So the file can be in the middle of changes. So it would be also nice to be able to swap blocks, to have a mechanism to swap blocks like atomically. So even if somebody is actively writing to the file, we can still swap block if it's not actively in use, and make sure there is no race between reading the block and replacing the block. But just a thought. Okay, if there are no other comments or questions, thank you very much.
Thank you.
Cool, thanks. Do you have any thoughts as to the timeline of when you'll open a PR? I know this is just like as you
would like
schedule
to
permits, but
open PR as soon as possible. Well, first I would like this security issue be solved first, because I depend a bit on the fix, because this is how I found it. I needed this for BRT, so I want this to be merged. I want to merge it to my branch, and then and I think it's pretty much ready to open a PR. It will be still missing tests, but I think it would be good to start a discussion and see what people think about the code itself. Because I don't yet know. Yeah, I know that Christian was taking a look, not sure if at the entire thing or just the zero part, but it needs much more review. So I think the code is pretty much ready for a PR. I just need this security fix in place.
that's great.
But no promises. Who knows?
Yeah. Thanks. Thanks, Christian, for taking notes. I see you typing in there in the doc. Next, should we talk about encryption bugs? Is Rich here? I don't see your name. He said he might not be able to make it. Is there anyone else working on this that would like to speak to the summary of what's going on with encryption bugs here?
I could take a shot. Can you hear me?
Yeah, thank you.
This is Georgia Manakis. So I was actually involved in solving two bugs. One of them I see Rich mentioned in the document. That was a problem mainly when raw sending snapshots to a target and then trying to send them back to the originating file system. That was not possible because of the user accounting being present. So we decided to work around that by actually resetting the flag in the OSFIS of the file system, and
Like to indicate
now
to indicate that there isn't accounting data anymore.
yes, it's actually indicating that it's not complete.
Got it.
So when we're sending it back, it will bypass comparing the local MAC, and so it now enables the sending back of snapshots to the originating data system. And as soon as the key is loaded and the file system is mounted, it will go on complete the user accounting by counting by including the new snapshot that was sent back in the user accounting, and the flag will be set again. So that's how we solved that. So the user accounting is always there. The D nodes are all D nodes are not touched. It's just a flag in the OSFIS that indicates that the user accounting is not complete. So don't go ahead and check the local MAC when raw receiving. So it was only a matter of skipping the comparison for the local MAC in case of raw receiving.
Cool.
There was a second one that is not mentioned. It manifested as an error, an unclear error, when again raw sending and receiving snapshots, but it was actually, so that was, I think, issue 12.720. So 12,720, where it manifested during raw sending, but the issue was only because the encryption code path was checking for discrepancies between the dnode bonus length and the dnode spill pointer flag. So actually, in very early releases of OpenZFS, this dates back to the 0.6 branch, I think, there was a fix. We could have dnodes written on disk where actually the bonus length and the dnode spill pointer flag were not in accordance with each other. So we could have written such dnodes on disk. And now the encryption code path, when raw sending and receiving, would pick this up and just error out. So I went ahead and filed a pull request. This is 13,014, so 13,014, where we actually, when we encounter such body D nodes whose bonus length is actually greater than the predicted one, when accounting also for the D node spill pointer flag, we report an error. And this is done during normal raw receiving and also during scrubbing. So now when we do a scrub and we pick up such faulty D nodes, we report an error. And I also added in that PR an assertion at the end of a D node sync, so that it can actually check for this discrepancy there too.
That's great. Thanks for all of your work on those.
Sure.
I saw that there's a few things mentioned here in the notes that Rich put in about works in progress. Do you know the status on those? Do you know if he's looking for help on those or if he's making progress on them?
As far as so from the other things that Rich has mentioned there, one bug that has drawn lots of attention because people are encountering it all over again is the 11679. As far as I can remember, he mentioned that in the last OpenZFS leadership meeting too. I think he thinks that there is a problem with the ref count accounting, either in the R code or in the debuff code. Code paths, that actually the ref count accounting is not done correctly, and so we can release a debuff, and then in the code path, for example, of debuff write, and then a debuff read is going on to access it, and it's no longer there, so it panics with a null pointer dereference. I think also he has submitted a draft PR, but I don't think it's final at this point. So I think he's still looking into it.
Okay, yeah, I see the issue. I'm not seeing a linked PR, but maybe it's just buried in here somewhere.
I can quickly let me see. Again, it's a draft PR as far as I can remember. Give me a minute.
I'm not seeing it on the last page.
It looks like it's 12943.
Yes, that's it.
Just on the-
12943. As I said, it's I think this is only a draft PR. He actually is going over the locking to see where if something can be if the bug can bypass with manipulating the locking, but I'm not sure that we actually know that the problem is there. It can also be a problem in the R code path with the ref count accounting.
All right. Well, it sounds like it would be great to have more folks who are familiar with the DMU take a look at that PR and the analysis that he's done. It looks like he has a bit of a write-up there explaining what's going on, so that's nice. Any other thoughts or requests for help on this encryption stuff? All right, then let's go to the next agenda item, which is the Blake 3 checksum. Tino added this item. If you're on the call.
Yes, I am here. Hello. Yeah, I just wanted to ask if the Blake 3 checksum stuff is ready for inclusion, or if there is anything left to do for me. I don't know. Also, it works nice. I tested it, and it seems also very fast. I don't know if you have seen some benchmarks against, for example, SHA new instructions from Intel. Blake 3 is mostly faster. I maybe put some benchmark results into the chat.
Yeah, sorry, my web browser just died while I was trying to bring up your PR.
Or you go into the pull request, and then in the end, there are some benchmarks about a month ago. There's a list.
I mean, I am not that familiar with PR, but I think that the idea of adding that sounds good to me. Has anyone taken a look at the PR? All right, I got the PR up. I see your benchmarks. Let's see, a couple of.
That's the micro benchmarking like it's done for Fletcher. It's the same meaning, and for 1K block, for 4K, 16K, and so on, and up to 4 megabyte block, and then the throughput in megabytes per second.
Cool.
I
Yeah,
even
nice.
implemented a SHA-2 algorithm with this, but it's not still a pull requested. I would open this when Blake is in, and then I would also do some SHA stuff. Then some different implementations for AVX and generic and SHA new instructions and so on.
So the PR that you have, is this just the Blake 3
That's
generic?
just the Blake 3 stuff, and the benchmarking of the implementation of the benchmarking, the checksumming, and then in later pull request I would also maybe add for SHA and maybe also scan assembler stuff, and then also some benchmarking, and then the fastest implementation is chosen when the module is inserted.
I see. And does your PR include the AVX versions of Blake 3? Okay, cool. Yeah, I mean, those numbers look great. I mean, it's way beyond, the AVX 512 is like, what, like 3 times faster than EDON-R and like 10 times faster than SHA. So that's really impressive. In terms of the security of Blake 3, like I'm not that up on any of that stuff. Is this a replacement for SHA in terms of like we can use it for?
I'm not a cryptographer, but it was, I think, in the SHA-3 contest within, but not this Break 3, but Break 2, and it was second place or the third, I don't know, and Break 3 even is in more advanced Break 2, and so I think it's safe, but that's not my. I don't have enough plan of this. I don't know.
Well, in your PR, are you allowing it to be used with dedupe without verification?
Dedupe is working with this.
Okay.
I tested. I don't know how more tests can be done, because the testing and set loop and so on, it looks nice. I think I have run it for some hours, and it should be okay, I think.
All right. I mean, that all sounds good to me. Any thoughts or objections from other folks?
I think we should really talk to some crypto expert if we can use this without verification, if it's not a standard hash function.
I mean,
it's a very
the credentials are pretty good, but I posted the link in the chat, but I don't know, like, what was the benchmark for the other checksums that were used in ZFS? Like, who admitted them?
Well, I think that the idea was, I mean, probably me or Brian, like, give our stamp of approval. But I think that the idea of the other ones was that like they had been kind of vetted extensively by third-party, stamps of approval. And the goal here is basically just that you could use it for dedupe and nobody can generate like a matching key. Or like nobody can generate another block that checksums to the same value as a given block. So they can't, like, you know, essentially corrupt your data. Like if there's two people writing to the pool, they're both using dedupe, you're not using encryption.
Right. There's no known way to craft a collision on purpose.
Yeah.
So Blake 3, I think that is the definition of a cryptographic checksum, and Blake 3 was a contender in the SHA contest by a quite renowned cryptographer. I can ask someone who is like doing a PhD in cryptography to weigh in on this. He is also a previous OpenZFS contributor. So I don't know, he has some domain knowledge. I think I can reach out to him.
Yeah, that would be great.
So note that Blake 3 is 2 years old, almost exactly. So it's very young still.
Yes, and it was designed to be fast and also secure in the same time.
Like every algorithm pretty much is, but with cryptography, of course, the older the algorithm, the more peer review it had, and of course it would be great to have like very fast, very strong, securely strong checksum. So, but yeah.
Yeah, I mean, given the performance, I mean, I'd love to see it in even as an alternative to EDON-R, which we don't accept as using for dedupe, but you know, it can be used for. I think we use it for not write detection, and it's obviously much stronger than Fletcher. So, you know, if we weren't going to use it for dedupe, then it seems like the bar is already met. I guess the question is, like, are there any concerns about, you know, unknown vulnerabilities that might make it not appropriate for dedupe? I think that was the concern with EDON-R, and that's why we didn't make it.
But what is the difference? What is the difference, like security-wise, between dedupe and NOP writes?
Well, with NOP write, you don't really have to be concerned about an attacker. It's only like accidental matches that we have to worry about, because, you know, if you can write to that location, then obviously you can write whatever you want. And so, you know, we weren't really concerned with the case where, like, an attacker can control what's written, but then, like, not, you know, we were really only worried about, like, you know, if you can control what's written, then you can write whatever you want. And so we weren't worried about somebody intentionally writing nefarious stuff.
You would need to have like intention to keep what's there already. That something is like malicious, or
yeah,
and
I mean,
you won't
the
be able
worst
to
case,
override.
exactly. Like, you know, I'm sure that somebody could come up with a scenario where there's a lot of parties involved, and one of the parties gets to decide what's written, and, you know, they somehow, like, they like, their right is going to get lost because they've constructed it so carefully. But it seems like, I don't know how you would use that to actually cause anything bad to happen to anyone but yourself. So I think that's why the bar was lower for that.
Because yeah, it's definitely different like level of threat, but it's also important, like you definitely don't want to leave like vulnerable binary only because the updated binary have the same checksum. So we definitely don't want this to be accidental, that it's possible to generate something similar, because like I also give this example sometimes in terms of like reproducible builds where OpenSSH had a bug, and the binary of OpenSSH, the secure one and the vulnerable one, was only 1 bit difference, because there was only a matter of changing the, I think, less sign to less equal. So and the binary resulted in just a single bit difference. So, but yes, you're right. It's much harder to exploit that.
Yeah. I think we're almost coming to the end of the time. I have a meeting right after this. So why don't we go on to, well, I guess let's conclude this by figuring out like, what are the next steps needed to get this integrated? I think one of them is to have this person who's working on their PhD in cryptography to take a look at it and just tell us if they think, based on kind of the consensus of cryptographers, does this seem like a relatively safe thing to do for this use case?
Yeah, I've mentioned him in the OpenZFS Slack channel. We'll respond there.
Cool, thanks. And then on the code review front, do you, like a few people had started looking at it, do you need more reviewers, or do you need those reviewers to take another look?
I don't know. I just need
This is about the Blake 3.
oh, sorry. No, sorry.
Oh, Tino, do you know?
Yes, I'm here. Sorry. From my side, it seems to work. The break 3 checksum is from cryptographers, of course, but I cannot speak for them. Yes.
I guess my question was about the reviewers, like Rich and I don't know the other person's name, HA6. Are they? Do you know if they're planning to do a review of like the ZFS parts of this?
I don't know.
Okay. We might need to coordinate. And Mark, I see you're on, but Mark is the
Mike. Yeah, Mike, of course, should maybe say something about it. Rins just tested the ARM stuff and also did the implementation of the Neon code, which is some assembler stuff.
Sorry, guys, I need to drop, but Mark, could you just give your thoughts and finish up the call for George?
Yeah, thanks. Yep, I had a drop. So yeah, so I'll definitely follow up with the code reviewers and make sure that they're happy with things. And I'll probably even take a look at it myself. There was another final item on the list? Is that right? That sorry,
Yeah, I just had a bunch of code reviews I have pending.
Okay.
That we would like to get wrapped up.
Okay, that's probably also me.
I think one of them is I know at least one of them is someone other than you. But,
okay, a BSD one.
Yeah.
Well, there's the Linux namespaces one, support for delegating a data set to a namespace on Linux, and basically implementing something similar to what FreeBSD can do with jails or Illumos with zones.
Right.
That one's been sitting there a while. I think the only thing, there's some idea we wanted to somehow take a reference to the namespace, but there doesn't seem to be an API for that.
Oh,
in Linux, it's Linux's poor design. I don't know what we want to do about that one. And then there's the SPA inflation one, just figuring out what that actually means. And then there's the right throttle one, which I think Alexander gave us a good review on that one, and we made some changes based on that. Found a braino in there, but would like to see what's required to move forward with that.
Okay, all right. I'll follow up with the ones at least that are assigned to me, and I'll see if I can ping anybody who's not me, who's in charge of
Thank
it.
you.
Brian,
Yeah.
you'll keep me honest on that one, I hope.
Yeah. No, I'm on the hook here to take another look at a bunch of these too. So
All right.
I'll do what I can.
All right, cool. All right, do we have anything else today?